Hello all, my name is Mekala Varshit Reddy, pursuing my BTech at Institute of Aeronautical Engineering. Today we are going to discuss about finding reusable UML sequence diagrams automatically. So before we dive into this video, let me give you a quick recap on what we are going to be discussing today. A small introduction about um UML and the diagrams. Basically, UML are like a diagrams or a design, we can say, for a particular object-oriented program, which represents the relationships between classes and their relationships between with interface and how uh, how can we design a program with a given problem statement. So without a further ado, let's dive into the video. So, reuser. Reuser addresses a common challenge in software development, the difficulty of effectively locating usable artifacts that can accelerate project timelines by employing structural relationship matching. Reuser enables user to leverage previously created designs and solutions, significantly and enhancing the efficiency of development process and encouraging best practices in software reuse. So basically, when you actually talk about UML, it is very important that the code is reused. See, when you write a program, it's not like you are writing a set of code and then forgetting about it. No. See, whenever we are creating a program for any application, it is mandatory that we follow some principles which makes it reused. See, for example, I take a web service, Amazon. Yeah, this web service, Amazon, has a piece of code, So it is, you know, suppose we are implementing a new application in this web application. It is mandatory that instead of scratching this code and writing a new code again and again, it is important that using the same code, let me erase it. Yeah. Using the same code itself, we can make some modifications. This can be happen by employing some principles. For example, it can be solid principles and some of the principles which makes our code more maintainable and reusable. So that's out of the way. One second. Yeah. Now, so it is a quick introduction about my topic today, what I'm going to talk about. So, uh, before we dive deep into this topic, let us discuss what we are going to be discussing today. First, we are going to be understanding why and how a code is reused using reuser principles and evaluating the reuser. This can be done basically. This is important basically when our code is in development stage. It is mandatory to be, tested, which makes it more maintainable and as well as less erroneous. Now, so and we are also talking about some case studies regarding reusability of our object-oriented code, structured based matching, and some of the future improvements in how we can make our object-oriented code reusable. Now, so let us first understanding what reuser means. See, reuser is a tool employ an algorithm that analyzes underlying structure of design artifacts, allowing for efficient searching based on similarities in architecture rather than content-based searches that require detailed metadata. By removing need for extensive annotations, reusers significantly reduces the overhead on developers, enabling them to focus on more critical tasks while benefiting from previously designed solutions. The system is capable of handling various types of artifacts, including code snippets, design documents, and architecture models, while making it versatile across different stages of software development. The user integrates with existing development environments, uh, providing user with a seamless experience without disrupting their workflow. Initial evaluation suggests that unless have experienced a reduction in time spent on artifacts retrieval, highlighting reuser potential to streamline the software development lifecycle. The technology behind reuser can adapt over time, learning from interaction, improving its matching capabilities, thus continuously enhancing its eff- efficiency and effectiveness. So that's what we are talking about. See, uh, writing code from scratch is different and reusing the same code is different. See, there are a lot of things when we try to negotiate with the use code with the new code, there can be slight adjustments and there can be slight modifications. See, mainly the let us assume that mainly our previous code is well designed and well planned. So instead of removing the same code and writing it from scratch, if it passes the testing phase, then it is important to maintain that code and reuse that. That's what the reuse stands by. See, this is the basic structure what we are going to be talking about. See, whenever whenever this is the customer who is going to be interacting with the interface. Now, what happens is in this UML structure, first the customer is going to be interacted. This uh, creates a new sale, right? See, let us talk about uh, Amazon interface. So what happens is when a customer interacts with the interface, a new sale is going to be created. This in turn makes a new state. See, what an application principle states that one user should not interact with another user, right? So that's what it is. A new state sale means new state where this new state is going to be interacting with the create sale function, and this create sale function is going to be calling the create function. Now, what happens is the additional details it is going to be fetched from add item. Cool. Now, this is the whole architecture of a simple web services, and the sale is broken down. Now, see, the sale is created, and now the sale is being utilized. See, this is the basic structure of a web service, uh, and we are going to be talking into in deep why we are discussing all this stuff. One second. So, the lab experiments conducted involved a diverse set of design artifacts, which allows allows for assessment of reuser performance across varying complexity levels, demonstrating its adaptability in different contexts. Participants in evaluation studies reported positive experience when reuser highlighted that it facilitated a quick access to relevant artifacts, thus streamlining the development process. See, that's the difference between a normal piece of code and a reuser code. See, what reuser code states that is instead of compromising the applications offered by previous apps, it basically states that a user can use the same application same uh, applications and in it can be applications or services. Instead of compromising on that, the services shall be just modified, not at all compromised. That's what makes it different from writing a code from scratch or reusing a code. So this is the small experiment conducted by the research team where where a small web service, you see, it is conducted on a set of individuals where they express their opinion on how reuse code is very useful, and this is how we can reuse a code. Here you can see this. This is a this was done in a ROS software interface, which basically used in designing an object-oriented program. So the 3 into 2 factorial design enabled researchers to systematically evaluate the interaction between different independent variables, contributing to a comprehensive understanding of how each condition affects the efficiency of reuser. Control groups did not receive any additional assistance, serving as a baseline to measure the effectiveness of alternative conditions introducing in experimental groups. One of the experimental groups was provided with access to a design library, allowing participants to determine how readily available resources impacted their ability to retrieve and apply reusable artifacts. In case studies, reuser demonstrates a notable ability to retrieve not only individual artifacts but also related sequence of artifacts, which are crucial for maintaining context and coherence in software design. The tool's performance was compared against traditional methods of artifact retrieval, highlighting a significant improvement in speed and accuracy of finding relevant information. The process of structure-based matching utilizes advanced algorithms to analyze the architectural layout of artifacts, allowing for identification of similarities that might not be evident through conventional comparison methods. By deriving structure similarity scores, the user can rank artifacts based on the relevance to user query, enhancing efficiency in retrieving the most penetrate artifacts quickly. This is the same code which we are discussed earlier. Now it's about a specification and a small structure about you know, recommendation system. So yeah, consider enhancements like parameter tuning, weighted structure matching, and improved visualization aim to increase usability and responsiveness based on user feedback. The reuser tool indicates significant promise for automating artifact retrieval in software engineering. Continue the evaluations and advancement could further solidify its utility as an indispensable tool for analysis. This is the papers which I have used in my presentation. So thank you all guys for sticking with me in this presentation. I hope you are doing well. Thank you.